We've been hearing about the rotation of Earth today and how that rotation gives us daytime and nighttime. And you've been very helpful, Cindy, in showing us why it's nighttime in China while it's daytime here in the United States.
And let's not forget that Earth and the Moon and the Sun have predictable motions, and those movements help us tell time. One rotation of Earth takes 24 hours or 1 day, and one revolution of the Moon around Earth takes 28 days or 1 month.
And one revolution of Earth around the Sun, how long does that take, Cindy?
Everyone knows that, Mackenzie. It takes Earth 365 days or 1 year to make a revolution around the Sun.
Somehow I knew you would know the answers. Thanks, Cindy. And how about you? Do you know the answers? Let's take another look at rotation and revolution.
The sun brings us light and it brings us heat. It is the source of Earth's energy. The sun is 150 million kilometers from Earth.
Being that far away, we just get a small part of the sun's energy. If we were closer, like say the planet Mercury, we'd get a lot more energy.
In fact, we'd get too much energy, making us too hot, and people wouldn't be able to exist. But on Earth, we get just the right amount of light and heat to survive. Earth revolves around the sun in an almost circular orbit, and remember that revolution takes 365 days or 1 year. But at the same time, Earth also rotates completely every 24 hours or each day.
When the side of the Earth that we live on faces the sun, we call that daytime. When the side of the Earth that we live on faces away from the sun, we call this nighttime.
Earth is tilted 23.5 degrees, and the North Pole always points to the North Star. Because of that tilt, different parts of Earth are closer to the sun at different times during the year. When the southern hemisphere is closer to the sun, it gets longer days with more direct sunlight. In this demonstration, the bright bulb represents the sun, and the student holds a globe with the North Pole always pointing to the North Star. So this would be winter in the northern hemisphere and summer in the southern hemisphere. Because of the tilt of the planet, there is no sunlight reaching the North Pole, leaving it in 24 hours of darkness. This is an extreme example of the shortest day for the northern hemisphere, which is the winter solstice. It is now fall since the sun is hitting the northern hemisphere and southern hemisphere equally. The most direct sunlight is hitting the Earth's equator. It happens at the beginning of fall and spring, and when that happens, it is called the equinox. Now it is summer in the northern hemisphere and winter in the southern hemisphere. The North Pole is lit up, and there is no sunlight at the South Pole. So the North Pole has its summer solstice, which is its longest day. Here we are back to another equinox with equal amounts of sunlight on the northern and southern hemispheres. And now we have gone 1 full year and are back to summer in the southern hemisphere and winter in the northern hemisphere. Remember, the seasons are reversed in the southern and northern hemispheres, as you can see from the sunlight hitting this globe.
So if you want to go snow skiing in the middle of July, you need to find a resort somewhere in the southern hemisphere. You need to go to New Zealand or down to South America, because that's when they're going to have the best snow.
And if you want to go walking on the moon someday, you might want to consider a career in science.
There's still much to be learned, and it's an exciting field. And I know that many of our fifth graders right now are going to find their way into that and produce great discoveries in the future.
But how about making a great discovery right now by answering this question? What would be different if Earth's axis was not tilted?